Unit 6, Lesson 9, Multiply and Divide One-Step Inequalities. Our last lesson we were talking about adding and subtracting. Today's is about multiplying and dividing one-step inequalities. Our essential question is, what is different when working with adding and subtracting, which you guys are familiar with, versus multiplying and dividing inequalities? So today's lesson is multiplying and dividing, and our last lesson was adding and subtracting. So what is different with these things? So we're going to be looking on how to answer that essential question for your summary. Let's begin with inequalities. An inequality compares quantities that are not equal. These are the signs. You know these from our last lesson. This is less than, greater than, less than or equal to, greater than or equal to. And now we have a matching. So go ahead and try this. Which one is less than? So start here and draw down to the less than. And how do you mark the less than point on a number line? Is it open or closed? It is open. Okay, go on to the less than or equal to. So find that one, match it up. Straight across. And how do you graph this one? With a closed point. Greater than or equal to, up here at the top. And this is another closed point. And finally the last one, greater than. And this is an open point. Just as a reminder from our last lesson. Here's some more reminders, some practices that you've already learned how to do. Practice naming the inequalities. So we're talking about the number 4 here. So we write down a 4, and then we need a variable. We'll just use x for this one. And then it is a closed point, so that is or equal to, and the arrow is going to the left. And so that is less than, like 3 and 2 and 1 and 0 and so on. So it is less than. So x is less than or equal to, because it is closed, 4. And you can always try some numbers out. Try 3, try 2, try 1, and they all work. This next one is 18, and we'll need a variable. We'll just use x again. This is an open point, and the arrow is still going less than, as in 17 and 16 and so on. So x is less than 18. Here we're talking about -1. We still need a variable of x. And it is an open point, but now the arrow is going to the right, and that is the graders. Graders over here, lessers over here. So x is greater than with an open point. And finally, we're talking about -9, and it is a closed point, and it is also going greater. So x is greater than or equal to -9. And finally, we're going to practice graphing the inequalities, which we learned about in our previous lesson. So it doesn't matter where you really determine where the 10 is going to be on the number line. You just pick a point and you call it 10. Now this is a point that's located right here on the number line, and this is a less than or equal to, so it's definitely going to be a closed because it can be 10, or anything less than that, so it's going to go to the left. This one, k, is an open point, so we're going to leave it open. We're going to call it -3, and k is greater than -3. So where are the graders? They are to the right. Now this one, G is in the wrong spot, and in our last lesson we learned how to read backwards. So we got to go this way to this way. So G, let's rewrite this. G is less than or equal to negative 5. So we'll pick a negative 5 spot here, and we will make it solid, closed point, because it's or equal to, and it says that g is less than or equal to 5, so it's going to go to the left side. And finally, we have another backwards inequality, so we need to read it backwards, starting with h, going backwards. H is less than 8. So then we'll put an 8 here. This will be an open point, and it says that h is less than, so it's going to go to the left. All right, so we got good reminders about what the inequality signs do, if they're closed or open, how to read a graph, and how to make a graph. All right, now we step down into what we're learning today. Rules, rules, rules. So what are these rules that we're learning about? They are the inequality rule. Okay, what is the inequality rule? When multiplying or dividing by a negative, you must reverse the inequality symbol. Okay, it's taught as a rule, but really it is the property of multiplication and division. This is the only thing you need to watch for that is different from solving equations. So let's look more into what this rule is and where it came about. So in this table here, we're going to be using the properties of equality, which you're familiar with. Let's fix that. Properties of equality. Perform each operation as noted to both sides of the inequality. And then you're going to mark them true or false. So this is telling us to add 3 to both sides of the inequality. So we're going to add 3 and add 3. And 16 plus 3 is 19. And 8 plus 3 is 11. Now, up here, 16 is true that 16 is greater than 8. We're going to move that sign down, and we're going to ask, is it still true? 19 is greater than 11? It is. So we're going to put a T right here for true when you add positive 3 to both sides. How about adding a negative 3 to both sides? So we're going to add negative 2, and we're going to add a negative 2. All right, we're going to draw our line. And 16 plus negative 2 with a t-chart is going to tell you it's going to be 14. And 8 plus negative 2 is going to be 6. So we're going to bring this sign down. Don't know what's happening here. Hold on. Okay, is it true that 16 was greater than 8? Yes. Is it still true that 14 is greater than 6? Sure is. So this is another true statement. So we're going to put a T there. Okay, we're going to move on to subtracting 6 from both sides. We're going to subtract 6 and subtract 6. 16 minus 6 is 10, and 8 minus 6 is 2. Bring down the sign. Is it still true? It sure is. Another true. Now we're going to subtract negative 4. That could be tricky. It looks like this. Subtract negative 4. Or you could put parentheses like that. Subtract negative 4. Okay, to subtract a negative, it's very confusing. So what we're going to do is we are going to use additive inverse. Try that again. Additive inverse on both sides. Additive inverse. That makes it hard problem easier. 16 plus 4 is 20, and 8 plus 4 is 12. Is it still true that 20 is greater than 12? Sure is. Another true statement. We're going to go down here to multiplying both sides by 3. So we're going to multiply by 3. We're going to multiply by 3. So 16 times 3 on your calculator is 48. And 8 times 3 is 24. Bring down the sign. Is it still true? It is. Another true statement. All truths. Property of equality. It's working. Multiplying by negative 5 on both sides. We're going to multiply by a negative 5 and multiply by a negative 5. Now a positive times a negative gives you a negative answer, and 16 times 5 on your calculator is negative 80. 8 times negative 5 is going to give you a negative answer, and that's negative 40. We'll bring down the sign. And is it still true that negative 80 is larger than negative 40? It's not. Negative 40 is closer to 0. Negative 80 is farther from 0. It is way smaller. And so we have found a problem here. Let's check our work to make sure we did it right. Is a positive times a negative actually a negative? Sure is. Okay, and is 16 times 5 actually 80? It is. I checked again. And we made no mistakes on this side. It is negative 40, so the sign, there's something wrong going here. So this is a false statement. Now we're going to try to divide both sides by a positive 4. We're going to divide this one by a 4 and divide this side by a 4. 16 divided by 4 is 4. 8 divided by 4 is 2. Bring down the sign, and it is still true that 4 is greater than 2. So back to a true statement. And now we're going to divide both sides by negative 2. Positive divided by a negative is a negative. 16 divided by 2 is negative 8. And positive divided by a negative 2 is a negative 4. Bring down the sign. Is it true that negative 8 is greater than negative 4? It is not. Check our math, make sure we're doing it right. We are. And so there's something wrong with the sign. So this is another false statement. So we found 2 falses in 8 problems of doing the property of equality. Okay, we're going to hold on to that thought, and we're going to come over to the scale, the balance here. Using a scale balance, where A is greater than B, substitute numbers of your choice to make it true. So I'm going to tell you to substitute A with 4, number 4, and you're going to substitute B with 2. So A is going to be 4, and B is going to be 2. So 4 is greater than 2, so that's why the scale is leaning to the left. So let's now try each of the below and label them true or false. All right, so these are all A's, and we're going to substitute the number 4 in for every one of these. So just to be creative, to be faster, we're going to make a giant 4. Okay, all of those A's are the number 4. Just an easier way to do it for the notes. And then we're going to start doing the math. This first one is 4 plus 2 is 6. Then we're going to do 4 minus 2 is 2. 4 plus negative 2 is 2. You can use a t-chart. 4 minus negative 2, that's hard to understand, so we're going to use additive inverse. 4 plus positive 2 is 6. 4 times 2 is 8. 4 divided by 2 is 2. 4 times negative 2 is negative 8. And 4 divided by negative 2 is negative 2. So we want to make sure that we got all of our math facts correct there. We're dealing with positives, negatives, adding, subtracting, multiplying, and dividing. And then we're going to come over to the next column where the B's are. Now B's are 2, so we're going to start about right here. Go up, and then down, and then make your 2. So we just turned all those B's into the number 2 with the substitution property. All right, let's start doing the math. 2 plus 2 is 4. 2 minus 2 is 0. 2 plus negative 2 is also 0. And 2 minus negative 2, a little hard to understand. So let's use the property of equality. And 2 plus 2 is 4. Excuse me. All right, 2 times 2 is 4. 2 divided by 2 is 1. 2 times negative 2 is negative 4. And 2 divided by negative 2 is negative 1. Okay, check our math, make sure they're all correct. And they are, and now we can compare the scale. We want to keep the scale the same way as it is. So we want A to always be greater than B. Let's look. we can see that 6 is greater than 4, so that's still a true statement. 2 is greater than 0, still true. 2 is greater than 0, still true. 6 is greater than 4, still true. 8 8 is greater than 4, still true. 2 is greater than 1, still true. And -8 is greater than -4? No, it's not. That's a false statement. -2 is greater than -1? No, another false statement. So let's zoom out here and look what happened. We have 2 falses over here, and we have 2 falses over here. All the rest of them over here were true. Something going on. Turn the paper over, and it says directions. Use the investigation from the 2 tables on the previous page to answer the following. Which specific actions cause the inequality to become false? Okay, let's go back up and look. We had this action when we multiplied by a -5 and we divided by a -2, and when we multiplied by a -2 and we divided by a -2. Okay, in those moments, that's when we had the errors. So what specific actions cause the inequality to become false? It looks like when we were multiplying and dividing specifically by what? Negatives. During the property of equality. Number 2. Without changing the terms, what can be done to the sign to make it true? Okay, so let's take, for instance, this one right here. It was -80 is greater than -40, which is false. What can you do to these without changing the -80 and the -40? What can you do to the sign to make it true? Well, you can flip it over, and wouldn't that be true? Yes, it does make it true. So you flip the sign over without moving the terms. Let's try another one. We had an answer of -8 is greater than -4. -8 is greater than -4. Let's see what we can do. Without moving the terms, still -8 and -4. To make it true, we would turn the sign around. Works again. Let's try another one that we had a problem with. Over here on the scales of justice, -8 and -4. -8 and -4. We were saying that -8 was greater because that's the heavier A side. Well, that's wrong. If we leave -8 there and -4 here, we turn the sign around. Now it's true again. And our last one was -2, -1. So -2, -1. The sign was this way because it was saying that the A side of the scale was heavier. And so that's not true. And so if we leave the -2 there and the -1 there, we could reverse the sign and to make it true. So did we answer the question? Without changing the terms, we didn't change the terms, they are in the same locations. What can be done to the sign to make it true? Well, we're going to simply say reverse it. Let's practice what we've learned. We have 8 we do's, and then you're going to try the you do's on your own. All right, A. This is x, so we want to locate x. Remember all these things that we talk about. X is right here. and then x is being multiplied by 8, so the inverse of multiplying 8 by 8 is to divide by 8. If you do it to one side, you do it to the other. This gives us a nice number 1, and x has been set free. The sign comes down. 40 divided by 8 is 5. So to graph this, we'll come down and we'll claim the middle one as 5. It is a closed point because it's or equal to, so make a solid point, and x is less than 5. Now to check it, we want to find a number that is less than 5, which would be 4. Okay, so we're going to go up here to the problem. 8 parentheses for the x is less than 40. What do we put in there? Well, we're claiming that 4 will work because it's under the arrow. And what is 8 times 4? 32. Is 32 less than or equal to 40? It sure is. So we know we have the right solution and our sign is facing the correct way. Okay, let's try another one. This is negative 4 times x, so we're going to divide by negative 4 on both sides. This does give us our 1 right here, and x has been set free. 20 divided by negative 4 is actually a negative 5. Okay, the sign comes down, but does it? All right, we'll talk about that in just a bit. Let's try graphing this. It is negative 5. It is an open point, and it's saying that x is greater, so it's going to go to the right. Now let's pick something that is greater than negative 5. How about negative 4, or negative 3, or negative 2, or negative 1, or even 0, or even 1? Pick any of those, or anything larger. So I'm going to pick negative 4. So what we're going to do here, write real small, well actually off to the side over here, we're going to go negative 4 parentheses for the x is greater than 20. That is the original problem. And we're claiming that negative 4 is under the arrow, so that is a solution. So we will put a negative 4 in here for substitution property. And what is a negative times a negative? It is a positive, and that's 16. Is 16 greater than 20? It's not. Something is wrong. And here is what is wrong. We divided one side by a negative, and we divided the other side by a negative. And isn't that what was happening right up here in the green? We divided one side by a negative and the other side by a negative, and the sign became false. Look over here. We divided one side by a negative and we divided the other side by a negative, and it became false. So we learned that when you divide by a negative during the property of equality, the sign has to reverse. So get rid of that sign and reverse it. And so that means our arrow is reversed, and it goes to the left because x is less than. Now pick something less than negative 5. How about negative 6? Why don't we erase the negative 4 and the 16 and put a negative 6 in here? A negative times a negative is a positive, and 4 times 6 is 24. Is 24 greater than 20? Yes. So that was one moment where the sign reverses. It doesn't happen every time. You just need to know when. And we saw here that when you divide by a negative on both sides during the property of equality, that's when the sign reverses. Okay, let's try another one. Here is C. We have a missing number right in front of the x. So what is missing right here? It's a 1. So that looks like negative 1 over 2. So this gives you options. We've talked about this in the past, and here are some of your options. You want to make this negative 1 over 2 into the number 1, so it will work to divide it by itself, negative 1/2. But there's another option, and a lot of you guys are starting to use it. You can also, let me just draw this real quick. This would give you a nice 1 right here. Negative 1/2 divided by negative 1/2 would be a positive 1. or you could multiply by its reciprocal. This would also give you a nice 1. Let's do that one because that's the easier and quicker way to do it. Okay? How do you know it gives you a 1? Well, a negative times a negative is a positive, and 2 times 1 over 1 times 2 is 2 over 2, and 2 divided by 2 is 1. So x is by itself. So if we multiply one side by negative 2 over 1, we're going to multiply the other side by negative 2 over 1. All right, and then 8 times negative 2 is negative 16. Without even thinking about it, I am multiplying both sides, and I am multiplying both sides by a negative. So there's something that's going to happen to this sign. Let's look back at what we learned. When we multiply, look at this, multiplying by a negative or to both sides, the sign became false. And over here in the scales, when we multiplied by a negative on both sides, the scale became false. All right, so what did we learn here? We learned about reversing it. Okay, so in this instance, since we're multiplying both sides by a negative, the sign is going to reverse. X is less than or equal to negative 16. Let's try it. Negative 16, it is a closed point, and x is less than, so it goes to the left. Now pick a number that it can be. So you can do negative 17. I would choose negative 18. That's what I would choose. All right, and you can put it right in here and do your work and find out that it is absolutely true. All right, moving on to D. 4 and x are being multiplied together, so we're going to use division. We're dividing by a 4 because we want to make this a positive 1. And because we're dividing by 4 on each side, the sign will stay the same. Negative 28 divided by positive 4 is a negative 7. Negative 7, it is an open point, and it goes to the left. Okay, you can always check it by choosing something smaller than negative 7, such as negative 100. And negative 100 times 4 is negative 400, and negative 400 is definitely smaller than negative 7. Even smaller than negative 28. Okay, now we're going to go to E. This now is division. X is being divided by 9, so a clever way to do this, there is a 1 here. A clever way to do this is dividing by 1/9 or multiplying by its reciprocal. You do it to one side, you do it to the other. This is going to give you a nice little 1 over here, and x will be left alone. Negative 3 times positive 9 is negative 27. And look here, we are multiplying both sides by a positive. Therefore, our sign stays the same. I'll do some other highlighting on these other ones here. Okay, this one up here, we divided by a positive, so the sign stayed the same. Okay, on this one over here, we divided by a positive, so the sign stayed the same. On this next one, we don't even see a number in there, but right in front of the x, right after the negative sign, is the number 1. So to get rid of that negative 1, you can divide by negative 1. And that's going to be x, and 10 divided by negative 1 is negative 10. And look here, we are dividing both sides by a negative here and here, so the sign has to what? Reverse. I did not graph the last one. Got to do that. Negative 27, open circle, x is less than. We're on a streak of less thans here if you look at our we-dos. And we are not breaking that streak right here. This is a closed point. x is less than or equal to, so it goes to the left. And then finally this one, not finally, but next to finally, is dividing by 2. That's a 1 right here. X is less than or equal to 30. It's a closed point. X is less than. Again, 7 less thans in a row. All right, let's see if we can break that on this last one. What's in front of the x you can't see? Oh, 1. So what are we looking at here? Negative 1/5. Remember, you can divide by negative 1/5, but that gets a little bit much work. So what can we do instead? Well, I'll erase all that. We can also multiply by its reciprocal, negative 5 over 1. If you do it to one side, you do it to the other side. This gives us a nice giant number 1. A negative times a negative is a positive, and 5 over 5 is 1. So x has been set free. Negative 35 can be changed into a fraction if you like. A negative times a negative gives you a positive number. 35 times 5 is, I think it's 175. Yep, 175. Now, notice that we are multiplying one side by a negative and multiplying the other side by a negative. So this sign has to do something. It has to reverse. And x is greater than 175. So 175, it is an open circle, and x is greater. Hey, we broke the streak, going greater now. So on our last question, you saw that we divided by a positive on both sides, and the sign did not reverse. Okay, you got loads of examples. You have the investigation on the previous page. You have some rules right up here that are saying all things that we discovered, and you have some reminders on what the signs mean, how to graph, and how to write an inequality. So there's a lot of tools here you can use as you pause the video and try I and J. Just try I and J. Pause now. Okay, we're back to look at I and J. I didn't quite complete them because I wanted to talk to you about something. I hope that you caught that on I you were dividing both sides by a negative, so the sign has got to flip. If you didn't catch that, you didn't learn what was happening in the lesson, so go back and review that. So this is 9, okay, and it says C is less than, so it's an open, and we're going to the lesser side. On J, we again divided by a negative on both sides, so the sign is definitely going to reverse. But here's the problem with this one. The B is in the back. And so on the previous lesson, we learned how to read backwards. So here's my little point here, and I'm reading backwards. B is greater than or equal to negative 5. So B is greater than or equal to negative 5. So those can be tricky because the sign is switching, but then the problem is backwards. So then you got to flip the whole answer over. So there's a reverse. This would be called a reverse. But then this right here is kind of called like you scoop up the whole problem and you flip it over to be this. So B is greater than or equal to negative 5. So we put negative 5. This is a closed point because it's or equal to, and B is greater. All right, so hopefully you had success with I and J. And now you're going to do a couple of easier ones, K and L. Pause the video now. Okay, we're back with these two. And you can see that on K, we multiplied. That's how I did this one. We multiplied by positives on both sides, so the sign does not change. And on L, we divided by a positive on both sides, so the sign does not change. But on L, you can see that the A is on the wrong side, so I had to read backwards. A is greater than -6 to graph it correctly. All right, go ahead and pause the video. You're going to try this whole string, M, N, O, and P. Be very careful. Some of them are flipping and some of them are not. Sorry, not flipping, reversing. Reversing. Pause now. Okay, we're back now, and make sure your eraser is ready if you have things wrong and you're not showing your work. All work needs to be shown on all notes for credit. So on M, you can see that we're multiplying by a negative on both sides, so the sign reverses. On N, we are dividing by a negative on both sides, so the sign reverses. On O, we are dividing by a positive on both sides, so the sign does not reverse. And then finally on P, we are multiplying by a negative on both sides, so the sign reverses. Now on P was the only one in the row that we had to read backwards. Okay, and that was x is less than. I reverse the sign that x is less than -40, so x is less than -40. All right, so that does it for multiplying and dividing one-step inequalities. And you have a lot of information now for your summary is coming up. Okay, now for the test readiness check. All right, you have a couple things here that you ought to be familiar with. Q is basically today's lesson. R is adding and subtracting inequalities and graphing. S is back to expressions. Remember, expressions do not have equal signs. And so this is your expression, and which of these is it equal to? Which ones are the same? Yeses or nos? And then finally, the word problem, T. It says, Hintok has saved $40. He earns $14.50 per hour at work. He plans to buy a plane ticket to Atlanta for $330. How many hours must Hintok work in order to purchase a ticket? Write an equation. Remember what an equation looks like? Looks something like an equal sign. You probably have a number over here that is a total that you are desiring, and then you have something on this side that probably has a variable. Okay? Probably has a variable. So pause the video and try Q, R, S, and T. Remember, on T, write an equation, you must have one, and then after you write it, then solve it. Pause now. Okay, we're back on Q. That was clearly a watch out right there. We're dividing both sides by a negative, and so the sign does reverse, what we learned in the lesson. Then we moved over to R, and we're adding, so we're adding, subtracting. There was no reversing when adding or subtracting, and you know that because you can look right back up here, and we went through all of this right here, and it didn't matter if we were adding or subtracting, positives or negatives, it did not matter. And right here, it did not matter either, so you never have to look out for that when adding or subtracting. So on R, we added 5 to both sides, and C is less than 110. Graphed it with an open circle. On S, it says which expressions are equal to this expression. So I did additive inverse right here. Do you see it happening? Then I distributed 8 times 1 and 2500ths and 8 times negative 3 and 2500ths A. Well, I got 10 plus negative 26A. I did use a calculator to help get that done. So 10 plus negative 26A is an answer, but we also know that means the same thing as 10 minus 26A, because if you did the additive inverse here, it looks identical to the answer. So I'll erase those. So that one's good. And then plus, since there's a plus sign here, I can commute the two problems. I can move the negative 26 to the front, put the plus sign, and put the 10 in the back, just like you can do this in elementary school. 2 plus 1 is the same thing as 1 plus 2. All right, so which ones work? Well, I noticed that this one is just like the bottom one. So that's a yes. This one has a negative 10, and negative 10 was never negative because look at the beginning. Positive 8 times positive 1 and 25 hundredths. That's a positive 10 all the way. That's not going to work. Now we have a positive 10 again, minus 26, and that's right in the middle, right here. Negative 16a, definitely not what you're supposed to be doing. If you chose this one, okay, I know that you're having some real difficulties. You are still trying to combine unlike terms. The 10 does not have an a, so it cannot be combined with a negative 26. You have to keep them separated. And then finally, 16 minus 3 and 25 hundredths a. If you chose this one, it's likely that maybe you just are having some multiplication distributive problems, or you have no idea how to do this. So you got to get some help. Ask your teachers how to do this one so you know how to do it. Okay, final problem. You're supposed to write an equation first. So Hintock is working $14.50 per hour. So I wrote this right here, $14.50 times how many hours? That's what we want to know. That's why the h is the variable. That's what we're looking for. Plus, he already had $40, and all of this side on the left side is supposed to equal this side. That's what he wants. He needs to know how much he needs to earn. So to start on this one, we're going to get rid of the constant first. Sounds familiar, I bet. So let's get rid of the constant by adding a negative 40 or subtracting 40. That gives us a nice 0 right here. And 1450h comes down, and 330 plus negative 40 or minus 40 is 290. Then we are going to divide by $14.50 on both sides. And that's going to give us a reason to use a calculator. So I'm firing up the calculator here. 290 divided by 1450, and I get 20. So H is 20. So what's that mean? Well, he needs to work 20 hours to earn enough for his ticket.